Hi again. This time we're going to talk about succession. The dictionary defines the word succession this way: the act or process of following in order or sequence. So it would imply a sequence of steps, one following the other. Or when we hear the word used when people talk about who is elected to office, they often say something like Obama succeeded Bush as president in 2008, meaning Obama followed or was next in sequence. In this section, we're going to study an ecological process or sequence called ecological succession, a series of predictable changes in an ecosystem or a community. So get your paper ready, and I'll see you on the next slide. As I said in the first slide, ecological succession is a series of predictable changes in a community over time. Every organism changes the environment that it lives in. As one species alters its environment, other species find it easier to compete and survive, and still others can't compete and survive. For example, lichen is a decomposer, and it adds organic matter and forms soil. Mosses and other plants then find it easier to colonize and grow, and we see the lichen in the middle here and the mosses kind of off to the side. More organic matter accumulates and other species move in, further changing the environment. There are two kinds of succession that we're going to look at in this section. Primary succession happens in an area with no existing ecosystem. Primary succession usually takes a very long time to reach the climax community stage, usually 100+ years. And we're going to look at that in a little more detail in just a bit. Secondary succession occurs after a disturbance in an already existing community that is not completely destroyed, such as after a forest fire. And here you see an example of what it would look like for secondary succession. Secondary succession usually takes less time for the ecosystem to bounce back. And again, we're going to look a little bit more in detail in that in just a bit. This is a map of Iceland, and if you take a look at the top, you see the Arctic Circle. So you kind of know where we are. We're way pretty far north in terms of latitude. Okay? There is a tiny little island by the name of Surtsey that we're going to focus our attention on right now. Surtsey is situated 75 miles southeast of the capital of Iceland, a town called Reykjavik. Okay, so the yellow arrow is pointing to Reykjavik right there, and you see the little circle with the star showing that it's capital. Surtsey is about 75 miles to the southeast of Reykjavik, right there. It's a tiny little island, and it was born with volcanic violence on the morning of November 14th, 1963. Let's take a look at Surtsey's journey. At first, the island of Surtsey was no more than a puff of sulphurous smoke rising inexplicably from the sea, observed by men on a fishing boat. However, by mid-afternoon it was very clear that the action of the surrounding waves indicated something solid and massive was pushing close to the surface of the water. By the next night, Surtsey had become a 30-foot high narrow ridge in the ocean. And it continued to erupt for days. The ridge growing and growing with each eruption. Rising out of the cold North Atlantic Ocean. Continuing to erupt with great regularity and frequency for the next 4 years. At one point, volcanic eruptions also produced a second island that you see here in the foreground of the picture. However, that island was not very compacted, and it was quickly swallowed up again by erosion in the ocean. Surtsey, however, survived. By mid-1967, the eruptions had pretty much stopped, and Surtsey was now a very identifiable island, looking kind of like this upside-down ice cream cone-shaped island, just about 1 square mile in area. While eruptions were still occurring, Surtsey was declared a natural reserve, and the first signs of life were found in the water around the island in the form of diatoms, tiny single-celled algae, possibly carried there on the legs and feet of wading birds looking for food during quiet periods between the eruptions. Not long after that, the first vascular plants were found. Vascular plants are plants that have a vein system in their leaves. These were found in 1965, most likely brought by wind and again probably on the legs or feet of migratory birds. But they were some sea rockets or sea sandworts or sea lime grass, a couple of which you see in the pictures here. Once producers took hold, scientists started to see more and more migratory birds. In fact, today there are several species of birds that have their home nesting grounds on the island of Surtsey. As more birds began to nest there, more sea life was also found there in the waters around the island. And if more sea life is coming, then more predators and prey are also being found. A pod of 70 gray seals have made the island their breeding ground, and various insects and spiders were found with much regularity in those early years. In 1994, biologists were very excited to find the first earthworm on the island of Surtsey. Yeah, it doesn't sound very exciting to us, but believe me, it was. Most likely, again, brought in by a bird. And in 1998, the first bush was found. So that's a big deal because bushes are woody, whereas moss and grass plants and things like that, the vascular plants, are soft green. Today, Surtsey is mostly covered by mosses, lichen, and grasses, with a few bushes. Since the chance to study primary succession is so rare, Surtsey is maintained as a pristine environment by the entire worldwide scientific community. Scientists have built a small hut near the edge of the island for scientists to bunk in for very short periods of time as they study the island. And they take great care to minimize the human impact that we have there, to the point of even disposing of their own wastes back on the mainland. Yeah. We continue to observe and learn about Surtsey and studying what's going on today and how it's going to evolve over the next millennium. Secondary succession, on the other hand, occurs much more often in nature, and we have lots and lots of chances to study this. Wildfires are one natural disturbance that give scientists an opportunity to study secondary succession. The recent wildfires allow ecologists to study how and in what order organisms return to their homes, if they return to their homes. Remember, secondary succession happens in an existing ecosystem when it is not totally destroyed. Okay, so Mount St. Helens, when Mount St. Helens erupted back in the 1980s, it totally wiped out and totally destroyed the forest ecosystem on the side of the mountain. So that would be primary succession all over again. This is an example of secondary succession. So no matter what the type, whether it's wildfire or tornadoes, here we have an example of a tornado path through central Illinois in last week's tornadoes near Washington, Illinois. Or floods. This is a picture of downtown Houston from Tropical Storm Allison that flooded downtown Houston. Or even a man-made disturbance, a new subdivision being built. Secondary succession happens when there are parts of the previous ecosystem that are still intact. and it occurs at a much faster rate than primary succession. So 3 to 4 years from now, this subdivision will not look like this. It'll look like this. And 15 to 20 years from now, this subdivision will look even more different. The trees will be much bigger, it will be a lot more settled, and it'll be more like a climax community, which is what we're going to talk about next. So natural disturbances are common. Biologists use the term climax community to describe a community that has reached a steady state of equilibrium or balance. Although now scientists are starting to believe that that idea is really more apparent than real. What they mean is that an ecosystem may get to this state of balance, but it's not going to stay in balance very long because communities get disturbed again. Some communities are disturbed so often they never really reach a state of balance. But still, biologists look for signs that an ecosystem is becoming more stable. Secondary succession in a healthy ecosystem following a natural disturbance often reproduces the original community. As you see in the pictures down here below, we have a hardwood forest with some berry bushes and a wildfire destroyed everything. And we see an order that certain things come back in, and we'll talk more about that in a minute. But when you look at picture number 8, it's the same as picture number 1. So a natural disturbance, the ecosystem tends to come back to what it was before. Some areas, though, are in different stages because we may have had some small disturbances taking place as well. When the disturbance is human-caused, like clearing the land for farming or a subdivision or logging, the ecosystem may or may not recover to its original state. Sometimes the ecosystem does not come back at all. Sometimes a new ecosystem comes about. So we see some differences there when it's a natural disturbance versus a human. Biologists also look for certain patterns in succession. And as we've seen by studying Surtsey, we see small plants coming back first. So in our fire here in picture 5, we see small grasses and small flowering plants, followed by progressively larger and taller producers, often ending in hardwoods and deciduous trees. Now on Surtsey, we're not going to see hardwood and deciduous trees, but we'll see woody bushes. Now that's for the plants. The consumers also follow a similar pattern. The small producers bring small consumers. The bigger the producers are, the bigger the consumers are, until we finally get top-level predators. But no matter which type of succession, we see these same patterns. Chance plays a large role in what happens to start this process, though, because whatever wind blows in, or whatever the water washes in, or whatever a bird or a bug brings in, that's what starts the process all over again with those seeds taking root. Okay, so what did we talk about in this section? Let's recap real quickly. We talked about primary and secondary succession. Primary succession where there is no existing ecosystem, like the island of Surtsey, or if a volcano explodes and totally obliterates whatever's on its mountainside. Everything starts over, versus an existing community and parts of that community or ecosystem are still left after the disturbance. We talked about pioneer species. So are the deer pioneer species? Don't know about that. Let's see. Nope, the deer are not pioneer species. Remember, the pioneer species are the first things to come back after a disturbance. And biologists look for patterns in the way things come back. Things usually come back small to large, whether they're producers or consumers. So those are the main things that we talked about. Okay? So next you need to draw a line at the very bottom, summarize your notes. Get with a partner, get with a couple of study buddies, chat, come up with some questions. Look back in your textbook. There's always good ideas for questions in your textbook. Okay? Bring your notes to class, and I will see you guys on Friday or Monday or whenever you're in class.